Alright, so this is problem number 82. The problem says, a uniform 7.0 meter long ladder of mass 15 kgs leans against a smooth wall. The ladder makes an angle of 20 degrees with the vertical wall and the ground is rough, not luff. Part A asks you to calculate the components of the force exerted by the ground on the ladder at its base. As you can see here, this is the diagram of the forces on the ladder. You have the normal force of the ground pushing up. You have the frictional force pushing sideways. You have mg, the weight of the ladder pushing down, and the contact force with the wall pushing to the right. So these are your force equations. Fy equals ng minus mg equals 0. Fx equals nc minus f equals 0, since the ladders are the rest. So from here we get several important relations. The first one is ng equals mg, that's normal force on the ground, equals the weight of the ladder. And we know that friction is equal to nu mg from its definition. So we can say friction equals nu mg. From this equation we get nc minus nu mg equals 0, which is, so we can say that nc equals nu mg. We also know from our previous derivations that for a ladder with nothing on it, nu equals cotangent theta over 2. So when we plug in the numbers for this, we have cotangent 20 degrees over 2, so that's the incline, 15 kgs as the mass, 9.8 meters per second squared as the force of gravity. We get that the contact force, which is also the frictional, equal to the frictional force, is 202 newtons to the right. And finally, we also need the normal force of the ground on the ladder. That's just ng equals mg. So that's 15 kgs times 9.8 meters per second squared equals 147 newtons up. But keep the camera rolling because we also have to do part B, which asks you to recalculate the coefficient of friction if there is a person of mass 70 kgs standing 3/4 of the way up the ladder. Okay, so here is a slightly modified diagram. You have to account for the atom mass of the person. So ng is larger to account for this. Also, the frictional force than the normal coefficient, and the contact force with the wall are also larger to compensate. These are the force equations. They're pretty similar to what they were before. We started with the same relations we started on part A. Here we say ng equals mpg, mass of person g, plus mg, the weight of the ladder. We also say that for the frictional force equals nu ng. From this, fx equals nc minus f equals 0. We also say nc equals f. So we can substitute what we got for friction into here and say nc equals nu ng. So for this, we're kind of stuck here until we move to the torque equation, which says ncd sine theta minus mpg 3/4 d cosine theta minus mg d over 2 cosine theta equals 0. For this, I use the pivot point to be the point where the ladder contacts the ground. So the ladder is essentially rotating along its contact point with the ground. Here, I then factored out d from the equation, as it's the same in all of these things. I substituted in the relationship we got for the contact force, nu ng, where ng is mpg plus mg equals sine theta, and move these to the right. Here we can also factor out g from the equation, which leaves us with our next to the last step, nu times the quantity mp plus m, that's total mass, sine theta, equals 3/4 mp plus m over 2 cosine theta. Moving these terms to the right side, we get nu equals this, 3/4 mp plus m over 2 over mp plus m tan theta. And when we plug in all the values, we get that we have a frictional coefficient of 1.939.